Jai Hind students, welcome to my YouTube channel. Students, there are no secrets to success. It is the result of preparation, hard work and learning from your failure. So students, never ever lose the childlike wonder. Show gratitude. Don't complain, just work harder and harder. Never ever give up. Actually students, in order to succeed, your desire for success must be greater than your fear of failure. So with that optimism in the bedrock of reality, let's start with this particular session. So in this episode, we are going to discuss a very interesting concept, and that is the case of movable pulleys. Till now, we have discussed numericals, based on finding the acceleration of the bodies constituting a system in which the bodies are connected through a string and over a fixed pulley. There we have discussed towards the acceleration of each of the bodies constituting the system is constant. But here, in the case of movable pulleys, when one pulley is fixed, the other is movable, then in such a case, the bodies constituting the system will have different acceleration. So these are the four questions which are based on movable pulley. Okay, in each of the four questions, all the pulleys are considered to be frictionless and massless. In all the four questions, the string is considered to be inextensible and massless. And in all the four questions, what we are supposed to do is, we are supposed to determine the acceleration of each of the bodies. Clear students? I repeat, in each of the four questions, we are supposed to find an expression for the acceleration of each of the bodies constituting the system. And look at four diagrams. You will find a common point. In each of four cases, there is a movable pulley. Here, pulley P2 is fixed, but pulley P1 is movable. Pulley P1 is movable. It will move along this string. It will move, right? This is fixed. This is movable one. In this case, this is the fixed pulley P1, while P2 is the movable pulley. It will have linear motion. Movable pulley P2 means it will have linear motion, isn't it? Here, students, P1 and P3, these are the two fixed pulleys, while on the other hand, this P2 pulley, it will move downward. Linearly, it will move downward. So it is a movable pulley. While in question 4, pulley P1 is fixed, but pulley P2 is movable. It will move linearly in the downward direction. Right? So all the four cases are case of movable pulley, where bodies constituting a system, they have different acceleration. Right? One more thing, students. From second law, we are aware S is equal to second equation of motion. S equals to ut plus half at square. Isn't it? We are aware of it. Now, if the bodies are considered to be initially at rest, then u would be equal to 0. Then S is equal to half at square. So, for a given time, that is, if t is constant, then acceleration would be directly proportional to displacement. So in a given time, if the bodies cover equal displacement, then they will possess same acceleration. And if the bodies possess or traverses unequal displacements in the same time, then the bodies will possess different acceleration. Here, in all the four cases, due to the presence of movable pulley, we will discuss that every body will cover different displacements. Right? So accordingly, the bodies will have, or it will rather possess, different acceleration. Clear? So, let's start with the first question. Okay, let's start with the first question. First question, as I mentioned, students, we are supposed to find out the acceleration of each of the two bodies, right? So let us consider this body to be having acceleration A1 and this body to be having acceleration A2 in the downward direction. Let us consider this, right? So what we now do is, let us find out first the relationship between A1 and A2. For that, students, what to do is, let's draw a reference line. This is a reference line, isn't it? And the length of this arm is approximately equal to the length of this arm. The string is taut, isn't it? So if this is X, this will be also X. This is a single string. This is a single string. And suppose the length of this portion is Y. So basically, students, you are aware, the rate of change of displacement, that is known as velocity, and rate of change of velocity, that will give us acceleration. So suppose the length of this string, this length, the length of the string is L. Therefore, L would be equal to X plus Y. Am I clear, students? Suppose the length of this string is L. So accordingly, L would be equal to X plus Y. Clear? So what we get is 2X plus Y is equal to L. L is constant. It is the case of an inextensible and massless string. So total length of the string, that will remain constant. Therefore, differentiating both sides with respect to time t, we get, what do we get? Twice dx by dt plus dy by dt is equal to differentiation of constant. L is constant, isn't it? So differentiation of constant is 0. Am I clear, students? So twice, this is V1 plus this is V2 is equal to 0. V1 is the instantaneous velocity of this body, right? The rate of change of displacement, that is, will give us the velocity. And here, the rate at which the value of y changes, that will give us the velocity of this particular body. Right, students? Instantaneous velocity. So again, let us differentiate both sides with respect to time. What we get is twice dv1 by dt plus dv2 by dt is equal to 0. Now time rate change in the velocity of the body, that will give us its acceleration. So this is twice a1 plus this is a2 is equal to 0, which implies that, students, a2 is equal to minus twice a1. Am I clear? So this is the relationship in a2 and a1. Now look, if this body accelerates in the upward direction, then this body will accelerate in the downward direction, isn't it? So negative sign suggests that both the bodies are having acceleration in the opposite direction. One body is having acceleration in the upward direction, then the other body is having acceleration in the downward direction. So first and foremost, friends, in the case of movable pulley, remember the bodies constituting the system will have different acceleration. So first step would be to find out the relationship between the acceleration. So here we have found the relationship. In magnitude, A2 would be equal to twice A1 in magnitude. Clear, students? So this could have been done by using your sheer common sense as well. That also I'll convince you, right? Let me convince you that method also by using sheer logic. This relationship could have been easily obtained. Okay, let me convince you then. What to do is, friends, suppose, let us consider this mass moves downward by a distance of 4 meters. I repeat, suppose this mass M2 comes downward by a distance of 4 meters, right? Now the length of the string is constant. So it is moving down by 4 meters. So actually, it has got two arms like this. So as a result, what happens is the new position of the pulley would be somewhat like this. So if it moves down by 4 meters, then here 2 meters of the length of the string will get adjusted, and here 2 meters of the string will get adjusted. So now it will be like this. So basically what I mean to say is that if this mass comes down by 4 meters, this pulley will go in the upward direction by a distance of 2 meters. And this is a string which will again be constant. The length of the string will also remain constant. So if this pulley P1 moves upward by a distance of 2 meters, this mass M1 will also move upward through a distance of 2 meters. So in the same time, this body is covering a distance 4 meters downward, while this body will cover distance 2 meters upward. Therefore, as acceleration is directly proportional to displacement for a given time, therefore we conclude that the acceleration of M2 would be twice the acceleration of M1. So the relationship between A1 and A2 could be obtained using sheer logic, right? Just try to visualize the situation. Try to visualize the body is falling down and covering different distances. Again, I repeat, students. If we consider this body to move down by a distance of 4 meters, then what will happen? This length of the string being constant, this pulley will have to move in the upward direction, and the string will always remain taut, isn't it? It has got 2 arms over here. So if it goes down by 4 meters, 2 meter length will get adjusted over this arm, and 2 meter length will get adjusted over this arm. So the new position of this movable pulley would be over here. It will get raised by 2 meters. Right? 2 meter, 2 meter, it will get adjusted on both the arms, isn't it? So as a result, if the pulley P1 moves upward by a distance of 2 meters, this mass M1 will also have distance 2 meters covered in the upward direction. So we notice during the same time this body will be covering 4 meters, this body will be covering 2 meters. And since A is directly proportional to displacement for a given time, therefore acceleration of this body will be equal to twice the acceleration of body of mass M1. Right? I hope you have understood this concept. Okay, now let's draw the free body diagram. Suppose this is the tension I'm talking about. This is a single string. So tension at any point would be same, like this. This is another string. So suppose this tension is T dash. Obviously, whatever force is exerted by this body on this body, the same force will be exerted by M1 on pulley P1 as per the action-reaction pair, right? So, let's concentrate on mass M1. Let's draw the free body diagram of M1. Okay, what are the forces acting? One is its weight, the other one is the tension T dash, and its acceleration is A1. Isn't it? So, what will be the equation? T dash minus M1G is equal to M1A1. Students, put this as equation number 1, right? Now let's consider mass M2, this one. Okay, its weight will act in the vertically downward direction. Tension is T, acting upward direction, and it is accelerating downward with A2. So what will be the equation over here? M2G minus T is equal to M2A2. What is the other relationship? A1 or twice A1 is equal to A2. This is the third relationship. This we have mathematically proved, as well as by sheer logic also it can be easily verified. Right? Third relation for this pulley, student. This is the pulley. The force acting on pulley P1 is P1 dash in the downward direction and P and T in the upward direction. Now students, we have considered the pulley to be massless, isn't it? All the pulleys are considered to be massless and frictionless. Therefore, the net force acting on the pulley is 0. Net force acting on the pulley is 0 since mass of pulley is negligible. Therefore, net force is mass into acceleration. If mass is 0, net force is 0. Net force 0 means net downward force must be exactly balanced by the net upward force. So these are the 4 equations to it. By using these 4 equations, we can always get the expression for A1 and A2. Right? Let's solve it then. Let's consider this one. From first, what we get is T dash, it can be written as twice T minus M1G is equal to M1A1. M1A1, right? Now consider equation 2. From second, what we get is M2G, right here, M2G minus T is equal to M2A2, M2, and in place of A2 you can write twice A1. Clear, friends? Now, in order to equate the coefficients, we can multiply it by 2. So, after multiplying by 2, we get 4 M2A1, isn't it? So, this is suppose equation 5 and this is suppose equation 6. Now students, observe these two equations 5 and 6. If we add, then the tension will get eliminated, right? So adding 5 and 6, what you get is, adding equation 5 and 6, we get 2t minus 2t get cancelled. So what we get is minus M1G plus twice M2G is equal to M1A1 plus 4 M2A1, right? Therefore students, A1 it would be equal to, okay, G can be taken as common, so what we get is twice M2 minus M1 into G divided by A1 can be taken as common, so here we get 4 M2 plus M1. So students, this is the answer. This is the expression for the acceleration of body of mass M1, right? Now what will be the acceleration of M2? It will be equal to twice of A1. So A2, it will be equal to twice of A1. So what we get is twice 2M2 minus M1 into G divided by 4M2 plus M1. So we have obtained the acceleration A1 and A2 for both bodies for mass M1 as well as for M2, right? Okay students, now let's consider question number 2, right? Again, in this case P1 pulley is fixed while P2 is movable. Now what we consider is, suppose body M1 is having acceleration towards right. Let us say it to be A1. And body of mass M2, suppose it is accelerating, getting accelerated in the downward direction. And its acceleration is suppose A2. So students, first and foremost, by sheer logic, we need to get the relationship between A1 and A2, as was done in the previous question, right? So let's try to find the relationship between A1 and A2. Suppose students, the body of mass M1 get displaced towards right by a distance of say 2 meters, right? Suppose it get displaced by a distance of 2 meters. This string will obviously get slackened by 2 meters, isn't it? Now, it should be taut always. So this pulley, it has got 2 arms like this, right? These are the 2 arms of the string. So if it tends to move through a distance of 2 meters towards right, this pulley will move downward through a distance of only 1 meter, because 1 meter will get adjusted over here in this arm and 1 meter of the length of the string will get adjusted in the other arm, so that the length of the string always remains constant and the string remains taut. This pulley must come down by a distance of only 1 meter. Now since this string is fixed, so as a result this mass will also come down by a distance of 1 meter only. So what we observe is, in the same time, if this body covers a distance of 2 meter, this body will cover distance of only 1 meter during the same time. So what we conclude is, the distance covered by body of mass M1 in the same time is twice the distance covered by the body of mass M2. Therefore, body of mass M1 should possess acceleration twice the acceleration possessed by body M2, isn't it? So what should be the relationship between A1 and A2? A1, it should be equal to twice A2. since acceleration is directly proportional to displacement for a given time. Clear, students? Again I repeat. If it goes towards right by a distance of 2 meters, then 1 meter will get adjusted over this side, this arm, and 1 meter of the string will get adjusted along this side. So that the string remain taut throughout. The pulley will come down, pulley P2 which is mover 1, it will come down linearly by a distance of 1 meter, and accordingly mass M2 will also come down a distance of 1 meter. So we are observing that mass M1 will cover twice the distance covered by mass M2 during the same time, and that is why this is the relationship, right? Now let's draw the free body diagram. This is the same string, so tension would be same. This is the tension. This is another string. Suppose the tension is T dash. Okay, now let's draw the free body diagram. Suppose for M1, its weight is M1G, reaction, it will act perpendicular to the surface on which it is placed, and this is tension T, and having acceleration A1 along this direction. So students, only force acting over here is T, because in the vertical direction there is no net motion of the body. So in the vertical direction, the body is under the influence of balanced forces. So what will be the equation over here? T, it should be equal to M1 into A1, right? Say this is equation 1. Now let's consider that M2. This is M2. So its weight is M2G, tension is T dash, and it is having acceleration in the downward direction. So what will be the equation for this body? It would be M2G minus T dash is equal to mass into acceleration. This is second equation. Now student, consider this pulley. We need to get relationship between T and T dash as well, right? Consider this pulley. This is it. The net upward force is 2T, right? Net downward force is T dash. Now students, as I have told you, we are assuming the pulleys to be massless and frictionless. It's of negligible mass, therefore net force is 0. Net force is 0 only when net upward force is balanced by net downward force, that is 2T must be equal to T dash. So these are the equations. By using, we can easily find out the expression for A1 and A2 in terms of M1, M2 and G. Right? Let's try, let's do it. Okay, let's make use of this equation. From second, what we get is M2G minus T dash. T dash may be written as 2T is equal to M2. What is A2? A2 is equal to A1 by 2. Right, students? Okay. Again, M2G minus twice, what is T? It is M1A1 is equal to M2 A1 by 2. Clear? So, let's solve it. So, M2G, it would be equal to twice M1A1 plus M2A1 by 2. So, it can be taken as common. 2 is LCM, so what we get? 4M1 plus M2. And over here, A1. And this is M2G. Therefore, students, A1 is equal to twice M2G divided by 4M1 plus M2. This is the acceleration of body of mass M1. What about the acceleration of body of mass M2 then? A2 is equal to half of A1, isn't it? Substitute the value of A1 over here. So what we get is M2G divided by 4 times M1 plus M2. So this is it, students. So this is the acceleration of the body of mass M2. Right? I hope you have understood the first 2 questions. So next 2 questions will be attempted in the similar manner. Let's try the third one. In the third question also, you can observe, students, there are 3 pulleys actually. Pulley P1 and P3, these 2 pulleys are fixed. while the pulley P2 is movable. So whenever there is a case of movable pulleys, then the acceleration of the bodies constituting the system must be different. And also all the pulleys are considered to be massless and frictionless, right? So the two bodies, their masses are given, one is of 2 kg and the other one is of 5 kg. So we are supposed to find out the acceleration. Suppose it is getting accelerated towards right. Let us consider it to be A1. This is the first body and this is suppose the second body. Its acceleration suppose is A2. This is fixed, rigid end, right? So there is a single string and there is another string. So again, let's find out the relationship between A1 and A2. Students, remember, in the case of movable pulley, these are the two arms, isn't it? Now this body, imagine this body to get displaced towards right by distance of 2 meters. So its new position will be somewhere over here, suppose, right? So this string will get slackened by 2 meters. It will get slackened by 2 meters, but it should be always taut, obviously. So it will get slackened by 2 meters over here. 1 meter will get adjusted over this arm, and the 1 meter of this string will get adjusted over this arm. So as a result, this pulley will get displaced in the downward direction by 1 meter only. Now since pulley P2 will get displaced by distance of 1 meter, therefore body of mass 5 kg will also get displaced in the downward direction by distance of 1 meter. So students, in this case, as was in this case, if the body of mass 2 kg covers distance of 2 meter towards right, then the body of mass 5 kg will cover distance in the downward direction of only 1 meter. That is half the distance covered by body of mass 2 kg. So in the same time, body of mass 2 kg will cover twice the distance covered by body of mass 5 kg. And since acceleration is directly proportional to displacement, therefore here A1, it must be equal to twice of A2. So this relationship is to be obtained simply by using your brain. Just visualize, just try to apply logic, right? Okay. Now let's try to draw the free body diagram, right? This is the single string. So this may be considered to be tension. Tension will be same. Okay. This is another string, so tension will T dash. Let's consider the equation for body of mass 2 kg. For 2 kg body, this is it. Its weight will be 2g in the downward direction, this will be the reaction. These two will balance each other. Net force acting is T and its acceleration is along this direction. Therefore, T would be equal to, net force acting over here is T, would be equal to mass into acceleration, twice A1. Right students? Okay. Let's consider 5 kg mass. Okay, it's like this. So, its weight would be 5g in the downward direction, tension would be T dash, acceleration in the downward direction is A2. Let's consider the equation over here. So what do you get? 5g minus T dash is equal to 5A2. Clear? And pulley is considered to be massless. So what is the net force acting on each of the pulley? It is 0. And that is possible only when net upward force is balanced by the net downward force. That is, net upward force acting on the pulley is 2T and net downward force acting on the pulley is T dash. So let's make use of these equations so as to solve the value for A1 and A2. Right? Let's try to solve it. So, from second, what we get is 5g minus T dash can be written as 2T is equal to 5A2. A2 can be written as A1 by 2. Also, 5g minus twice, T is twice A. It is 5A1 by 2. Okay, let's solve it. 5g is equal to 5A1 by 2 plus 4A1. So, it will give us A1 is equal to 10 by 13 into G. This is the answer. This is the acceleration of the body of mass 2 kg. So what about the acceleration of body of mass 5 kg? A2 is equal to A1 by 2. A1 is equal to twice A2 or A2 equals to A1 by 2. Substitute this value of A1 over here. So acceleration A2 would be half of this. So A2, it would be equal to 5 by 13 G. So this will be the acceleration of the body of mass 5 kg. Clear, friends? I hope you have understood this question. All the 3 questions are based on the same concept. First, you need to determine the relationship between A1 and A2 and then proceed accordingly using the free body diagram. Right? Okay, let's attempt the last question then. Again, it's very, very interesting one. Let's try to attempt the 4th question then. Here again, before drawing the free body diagram, we need to find out the relationship between the acceleration of the bodies. So what we do is, let's find out the acceleration relationship between the acceleration of the bodies. Here both the bodies are given to be of equal masses, each of mass m. Pulley P1 is obviously fixed, pulley P2 is movable, and as per our assumptions, we are considering the pulleys to be massless as well as frictionless, right? So, let us assume this to be first body and this to be the second one. Let us assume this body to be moving in the upward direction and having acceleration of A1. Obviously, if this moves upward, this will come down, and this is suppose coming downward with acceleration of A2, right? So what we've assumed is, let A1 and A2 be the acceleration of the bodies of masses 1 and 2 respectively. These are the 2 bodies constituting the system. Now students, we are supposed to find out the relationship between A1 and A2. Very, very interesting one, right? Now look, same, let's find the relationship using the same logic as we have done in the first 3 questions, right? What we do is, let us consider this mass, first one, to move upward through a distance of 1 meter. Let it get raised, let it move upward by a distance of 1 meter. Right, students? So, the string will get slackened by 1 meter. So, this one, when it comes down by 1 meter, the length of the string will be constant, right? This length of the string is constant. So, it is but obvious that if this mass moves by a distance of 1 meter upward, this pulley will come down by a distance of 1 meter. The pulley will come down by a distance of 1 meter, like this. So this pulley will come down by a distance of 1 meter. Now here 1 meter and here 1 meter. So this length of the string again will remain constant. So as a result, 1 meter, 1 meter. So as a result, this mass will come down by a distance of 2 meters. So as to keep this string taut, right? In order this string to remain taut, this body should come down by a distance of 2 meters. That is, in the same time, this body will cover twice the distance as covered by body 1. Again, I repeat, students, it's a very, very interesting one. If this body is assumed to move upward by a distance of 1 meter, then the length of the string being constant and it is inextensible, this pulley P2 will go down by a distance of 1 meter. No doubt regarding this. If this moves up by 1 meter, this pulley will come down by 1 meter. Now when this pulley comes down by 1 meter, then this length of the string is also constant. So it has got 2 arms, so here 1 and here 1 meter. So as a result, in order for this string to remain taut, the total distance through which the mass m or body 2 will move downward will be 2 meters. That is, for the same time this body 2 will cover twice the distance covered by body 1. Therefore students, A2 must be equal to twice A1. Clear? This is the relationship between A1 and A2. Now let's draw the free body diagram. This is tension suppose. This is T dash. since the pulleys are massless, so net force acting on each of the pulleys would be 0. Let's draw the free body diagram for 1. For body 1. Okay, this is it. Its weight will act in the downward direction, this is tension, and it is accelerating upward. So T being greater than mg, the relation would be T minus mg. This is the net force acting on this body, and it is equal to mass into acceleration. Mass is m into a1. Right, students? Okay, let's consider for body 2. For body 2. This is the second body of same mass. Weight mg will act in the downward direction. Tension acting is T dash. Isn't it? Your tension acting is T dash. And it is getting accelerated downward with acceleration of A2. So mg must be greater than T dash. What will be the relation? Mg minus T dash. This is net force. It is equal to mass into acceleration. That is m into A2. Right, students? Also, consider pulley P2. Consider pulley P2. This is the pulley. What is the net downward force acting? This is it. This is T dash. This is T dash. What is the net upward force acting? It is T. Now since the pulley is massless, so net force acting on it is 0. Force is equal to mass into acceleration. If mass is negligible, the net force acting on the body is also negligible. Therefore, net force is negligible means net upward force must be balanced by the net downward force. So T, net upward force, must be balanced by the net downward force. Clear? So these are the equations. By using, we can easily get the expression for A1 and A2. Students, let's try to solve it. Okay. Over here, from 1, in fact from second, what do we get? T minus, in place of T, we can write 2T dash. 2T dash minus mg is equal to m into A1. Right? Put this as equation 4. Now from third, what we get is mg minus T dash. This is mg minus T dash is equal to m into A2. M, A2 is twice A1. Right, students? Now, in order to equate the coefficients, let's multiply throughout by 2. Let's multiply this equation throughout by 2. So, what do we get is minus 2T dash plus twice mg, isn't it? Is equal to, we are multiplying throughout by 2. So, what do we get? 4 times m into A1. Put this as 5. Now we can add 4 and 5. Adding 4 and 5, we get, why we are adding? Because this is 2t dash, this is minus 2 dash. So on adding, t dash will get eliminated. So 2t dash minus 2 dash get cancelled. Minus 2mg plus 2mg minus mg plus 2mg. It is equal to ma1 plus 4ma1. Right? Therefore, students, mg is equal to 5ma1, which implies that a1 is equal to g by 5. So this is the acceleration of body 1. Therefore, what about the acceleration of body 2? A2 is equal to twice A1, isn't it? A2 equals to twice A1. So what about the acceleration of body 2, this body? The acceleration will be twice of this. So it will be equal to twice g by 5. So student, this is the answer. Right? So I hope you have understood this concept. This is a very, very interesting and conceptual concepts. Right? So that's it for this particular session. Do join me in my next lecture then. Thank you and have a blessed day. Thank you.